We are discussing the scheduling algorithms in operating system. So the scheduling algorithms are first come first serve, FCFS. Then we have shortest job first, priority scheduling is there. Then we have round robin, and more of these are multi-level queue scheduling and multi-level feedback queue scheduling. We'll take these four first and we'll say the examples also. First come first serve or FCFS scheduling is that jobs are executed on first come and first serve basis. Means the job which has come first will be served first. The job which has come after it will be served after that. This is quite easy to understand and implement, so no complex logic is involved, and the performance is poor because the average waiting time, because the process which are waiting may be quite longer. And the example would be something like this. If we have process 1 to 4 and these are the burst time, these are the burst cycle or the CPU cycle time they would require to complete. They want this much of time to complete themselves. What happens when P1 comes? It will start from 0. This is a Gantt chart for these processes. So up till 21 it will go because 21 time it need. After that, because it has come first, it will be served first. Then P2 has come. Now it will be served. So 21 to 24 it required 3 burst time of 3 CPU cycles. It will run for 24 till 24. Then P3 has come. P3 will be catered, and then finally P4. So what will be the waiting time? P2 has to wait 21. P1 has to wait 0. So P1 has to wait 0. P2 has to wait 21 cycles, 21. P3 has to wait from here to here. So it will be 24. And P4 has to wait from 0 to 30. So that is 30. So if we add all these and divide it by 4, it will be 18.75 millisecond, right? Then shortest job first. Shortest job first means as the process arrives or process are coming, say P1 to P4 process are in ready queue. They are in ready queue. Now these needs to be processed. So when they need to be given to CPU, the CPU must know in shortest job first scheduling that the time required for each of them to complete. Is it possible? How the process or how the processor is going to know prior that what time they are going to need? So quite impossible to implement, but we'll still see the average waiting time. 21 to 3, 6 and 2. Just compare. P4 is the shortest job time it will take to complete. So P4 will be catered first. After that it will be 3. So P2 will be catered. Then it will be P3 because now if you arrange them in the say ascending order, you will see 6 will come after 3. So now P3 and finally 21 is the largest. So 21 will be catered. So what will be the waiting time? 0 plus 2 plus 5 plus 11 means P4 has to wait 0, P2 has to wait 2, P3 has to wait 5 and P1 has to wait 11 say millisecond. If you add them and divide by 4, it will be 4.5 milliseconds, quite good. So we can have a preemptive shortest job scheduling also. Jobs are put into ready queue as they arrive, but as soon as the process with shortest burst time arrives, the existing process will be preempted. This is the arrival time which we have added. This is the column of arrival time. These are the burst time, that is these are the time which these processors are going to take to complete themselves. See, when at the time 0, nothing is there, only P1 is there, so P1 will remain here. After this, P2 has come at 1. So at 1, this has the greater in the shortest job, means this is the shortest. So P2 will be given the CPU cycles and it will complete itself till 2, because at 2 this 6 has come, but there is no problem, 6 will not be catered. But at 3 2 has come, So it will go up to 3, but at this point 3, P4 has come. P4 has come. So P4 will be given a chance. P4 will given a chance, and now P4 will complete. It requires only 2. So P4 has to wait 0 time. Now, as we have just seen that P4 needs only 3, it is completed. So P2 is requiring only 1 cycle, so 1 cycle it will complete, right? Now P3, because it has come at 2, but because of P2 and P3 it has to wait here. And how much wait it has to do? 6, because at 6 it will start, but it has already come at 2, so it has to wait till some time. Then next is P1. P1 has already completed 1, so it has to wait from 0 to this 1 to 12. So this has to wait till 12 minus 1, that is 11. And then this P3 has to wait till, because P3 has to wait from here, and it has already come at 6. So 6 minus 2 will be with the waiting time of P3. How about P2? P2 will do what? P2 has completed, it has come at 1, and at the time it has come, P2, it has been given chance. So it has to wait nothing here. But P2 has to wait for this to complete so that it can get another chance. So 5 minus 3 is the waiting time of P2. So what is the waiting time? 5 minus 3 plus 6 minus 2 plus 12 minus 1. So you can just calculate it. It will be 2 plus 4 plus 11 by 4. So this will be 4.25. The average waiting time for preemptive shortage of first scheduling is less than both non-preemptive SJF scheduling and first come first serve scheduling. Priority scheduling. Priority scheduling is based on the priority. The priority is assigned to each of the process, and the process with the highest, the lowest priority number is the highest priority. So the process with highest priority is executed first, and so on and so forth. And process, when they come with same priority, they are executed in first come first serve manner if they have the same priority. And how the priority are decided? The priority are decided on the basis of memory requirement, time requirement, and any other resource requirement. So what will happen here? First of all, P2 will come because it has the least priority, means the greatest priority and least number. Then 2, that is P1 will come. Then the 3, this P4 will come, and then that finally this P3 will get a chance. What will be the average waiting time? 0, 3, 24, 26. Add them, divide by 4, it will be 13.25. Round robin. Now there are some advantages and disadvantages we have seen in the previous scheduling algorithm. Round robin wants to manage it. So what we can do here is we can give some chunk of time or CPU cycle, and we will decide it prior. Say in this example we will give only 5 cycles to any process, and when this is completed the chance will be to the next process. So every process will get a chance to get into the CPU first of all, right? How it happens? See, first of all this P1 will come. So P1 will come, it will go up to 5 because the quantum time is 5. After that it has to be preempted, it will be taken off. Then next one is P2. P2 will come, it only takes 3, the quantum time is 5, so it will be completed prior to that. After that P3 will come. P3 requires 6. We have given the time as 5, so it will complete, or it will go up to 13, and then it will again come out. It will be placed in the ready queue, or say waiting and then ready queue. Then P1 will come, right? Again, see P1, P2, P3, P4, P1, P2, P3, 4, like this. So what has happened? P2 is already finished, so P2 will not come here again. After that, after this completion, P4 will come, but P4 only requires, P4 how much it requires? Only 2. So 13 to 15 it will complete, and it will not come again. You will not see P4 and P2 again here. But as this is completed, P1, P3 are still remaining. P1 will come, it will go for 5 cycle. Then it will again go back to the ready queue, and then P3 will be taken, and P3 only requires 1 because 5 is already completed. So 6 minus 5, 1 cycle is needed. So 1 cycle it will complete, and then P1 for 5, then 5, and only after that one is needed because it is 21, so it will complete here. The average waiting time will be 11 milliseconds. You have to take the waiting time also in the waiting queue. How to compare the scheduling algorithm, that is what are the disadvantages and advantages of various scheduling algorithm we have just seen. First come first serve. It doesn't involve or include any complex logic. We just have to put the process or take the process requests in a queue and execute it one by one the way they have come. So Fcfs is pretty simple and easy to implement, and every process will get a chance to run and there will be no starvation. The disadvantage is there is no option of preemption of this process. If a process has started, the CPU executes the process until it ends. And since there is no preemption, if process is executing for long time, the processes in the back of the queue which are waiting have to wait for a long time before they get their chance to be executed. Next is shortest job first, SJF, and as we have seen in the definition, the shortest job are executed first and then the longer one, and then by this way. So in ascending order of time they will be taken care. The throughput is increased because more processes can be executed in less amount of time. But what are the disadvantages? How to know beforehand by CPU that which process is going to take what time? Okay, so this is a challenge, and longer process will have to have more waiting time, and eventually they are going to suffer the starvation. So preemptive shortest job for scheduling will have similar advantages and disadvantages. Round robin, what happens? The advantages are each process is served by CPU for a fixed quantum of time. So all the processes are given the same priority. Starvation will not occur because of each round robin cycle. Every process is given a fixed time to execute and no process is left behind. But this disadvantage is it totally depends on the quantum time you have taken. If you have taken larger time, means the choice of length of time, if it is longer, then it actually becomes as Fcfs. If the time quantum is shorter, then the context switch will be too much because the process has to be taken in, taken out from the CPU cycles. So that will increase the overhead and that will lead to the decrease in the CPU efficiency. Priority based scheduling, what are the advantages and disadvantages? In the priority of a process can be based on various parameters: memory requirement, time requirement, or user preference. For example, if you have a high-end game with better graphics it requires, that means the process which updates the screen in the game will gain the higher priority just to achieve better graphic performance. And sometimes you may not want that, but this is the advantage that you want. It will happen as the priority goes. The disadvantage is that if the priority are same, the processes are coming with the same priority, the second scheduling algorithm has to be used. That is, it will be Fcfs again. In preemptive priority scheduling, the higher priority process can execute ahead of an already executing lower priority process. So if the lower priority process keeps waiting for this higher priority process to complete, the starvation will occur. So let us see certain situation in which situation you have to use what. Situation 1 is what? The incoming processes are very short and there is no need for the process to execute in a specific order. In this case, which one is the best scheduling algorithm? Fcfs. This works best as compared to SJF and RR because the processes are short, which means that no process will wait for a longer time. And when each process is executed one by one, every process will be executed eventually. The situation 2 is like this. We have long and short processes, mix of this is there. And the task will only be completed if all the processes are executed successfully at a given time. Here, round robin scheduling will be the best because it does not cause starvation and it will also give equal time quantum for each process. Situation 3. We have user-based and kernel-based process. The processes are blend of this. Here the best is priority-based scheduling because the kernel-based process, they have higher priority than your process or user-based process. For instance, the scheduler itself is a kernel-based process, so it should run first so that it can schedule other processes. So this was about the scheduling algorithm. We have seen the examples also, and we have seen the advantage, disadvantage along with when to use what. Thank you so much. Take care of yourself.